Welcome back to our journey in exponents. Today we're going to talk about how we read numbers in scientific notation. So scientific notation is when math and science collide, and it helps us deal with numbers that are very, very large or very, very small. Go ahead and pause, add this to your table of contents, and tell your brain that we're working on knowing what scientific notation is, and we're going to figure out how we can write numbers in standard notation. All right, let's start off with a little video.
Have you ever wondered how far away the moon, the planet Saturn, or even the nearest star is to us here on Earth? Well, scientists do know. The moon is 240,000 miles away. Saturn, 745 million miles away. The closest star to our solar system, Proxima Centauri, is 25 trillion miles away. I can't even imagine how far that is. Anyway, if scientists had to write out all those zeros every time, they'd run out of room on their notepads or computer screen and waste a lot of time. Luckily, there's an easy way to write out really big or really small numbers called scientific notation, without all those zeros. Here's how it works. Really large or really small numbers are written as a product of a number between 1 and 10 and a power of 10. The distance to the moon is rewritten from 240,000 miles to 2.4 times 10 to the 5th miles. The distance to Saturn becomes 7.45 times 10 to the 8th miles. And Proxima Centauri is now 2.5 times 10 to the 13th miles away. That's a lot easier than writing out all those zeros. Like stars and planets, numbers come in all sizes, and we need an easy way to represent them all. And that's why knowing math matters.
All right, thanks, Math Matters guy. So those really large and really small numbers are awkward and take up a lot of space. Later in this unit, we're going to look at how to add, subtract, multiply, and divide them. And so we need them to be small and easy to work with. Scientific notation comes in handy for that. So the way it works is we have a number between 1 and 10. So it's greater to or equal to 1, but it's also less than 10. And then it's multiplied by some kind of power of 10 written in exponential form. Okay, go ahead and pause, add that to your notes. Oh, get that out of the way for you. All right, so today we are going to practice reading these, and tomorrow we will learn how to write in scientific notation. Okay, well, first off, we need to understand what powers of 10 even mean, which we already know. So 10 to the first power is just 10. 10 to the second power is 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000, and so on and so on. And as you can see, the exponent matches the number of zeros. When we multiply by a power of 10, let's see what happens to the decimal. So if we go 4 times 100, we're going to move the decimal. Oops, we're going to move the decimal twice, and that's going to give us 400. If we multiply by 1,000, that's 3 zeros. We're going to move the decimal 3 times and fill in with zeros, giving us 4,500. And if we multiply by 10,000 over here, which is really 10 to the 4th in disguise, we're going to move the decimal 4 times. Boom, 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 boom. Fill in with a couple zeros. And there we go. So what we can notice from that is the exponent tells us how to move. If it's a positive power of 10, we end up moving the decimal to the right the same number of spaces as the exponent. So when we had 10 to the second power, we moved the decimal twice. 10 to the third power, moved it 3 times, and so on. Okay, negative powers of 10, remember, is really a 1 over 10 to the first power because we throw it in the upside down. And this is 1/10, and the way we'd write that as a decimal is 0.1. 10 to the negative second is really 1 over 10 to the second, which is 1 over 100, which is 1/100th. 10 to the negative third is 1 over 10 to the third, which is 1 over 1,000, which is 1,000th. And last but not least, 10 to the negative fourth is 1 over 10 to the fourth, which is 1 over 10,000, which is 1/10,000th. Boop. Okay, so what happens if we multiply these guys? Well, I'm going to throw my 4.0 on top there. I'm going to multiply it by 0.01. So 40 times 1 is just 40. And then I end up with 1, 2, 3 moves, 1, 2, 3 moves, fill in with 0. Okay, let's do this one over here. I have 4.5 times 0.001. 1 times 45 is just 45. And then I have 1, 2, 3, 4 moves. 1, 2, 3, 4 moves. One of these days I'll learn how to write. And my pretty version over here gives me that. My pretty version up here gives me that. I don't need to put that extra 0 on the end. Part of the point of scientific notation is shortening stuff up, not making it longer. All right, and last but not least, I have this problem right here. Multiply it by this. 1 times 367 is just 367. And I'm going to need to go 1, 2, 3, 4, 5, 6 to get the decimal out of there. 1, 2, 3, 4, 5, 6 to put it back. And then if I look at my nice pretty version over here, okay, I get that. So what happens? If I look at my starting version and my original version, to get from here to here, I end up moving the decimal 2 times. It started out behind the 4, and it goes 2 moves to get to there. To get from here to there, I end up doing 3 moves. I start behind the 4, 1, 2, 3, and there we go. Same down here, surprise, surprise, to get from here to there, it ends up being 4 moves. And what do we notice over here with our exponents? Okay, that tells us we're moving twice, 3 times, 4 times, just like before, but the only difference is now with the negative exponent, we're going to the left. Okay, so go ahead and pause and write down this top part right here. Okay, so our first step is we're going to look at the exponent to figure out how to move the decimal. So we have a 6 right here that tells us we are going to move 6 spaces. Go ahead and pause and write that down. All right, for step 2, we're going to write that first number, and then if it's a positive exponent, we're going to move our decimal to the right. If it's a negative exponent, we're going to move our decimal to the left. So in this example here, we're going to write our starting number here, the factor. And since it's 6 and it's positive, I'm going to move 6 jumps to the right. So go ahead and pause and write that down. And last but not least, let me move this down for us. Boop. Oh, goodness. We get our final answer. So you just fill in with zeros, add commas as needed, and make your answer nice and pretty for the end. Okay. Let me show you how it all comes together. So step 1 is I look at the exponent. Okay, what does it tell me? It tells me I'm going to move 4 times, 4 spaces, and is it positive or negative? It's positive, so that means I'm going to the right. Okay, step 2, I'm going to write that first number there, 7.32, and now I'm going to do what I figured out. 1, 2, 3, 4. In step 3, I'm going to make it look nice. I'm going to fill in with zeros. I'm going to add commas where needed. You count every 3 in, and then you'd add a comma. And I'm going to make a nice pretty version at the end here that's all nice and lovely. Okay, let's look at this example here. Step 1 is I look at the exponent. That tells me I'm going to move, you guessed it, 8 spaces. And it's positive, so I'm headed to the right. Okay, step 2, I write this business down. Okay. Slap that negative on there for now. And I'm going to move 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Step 3, I make it all pretty. I'm going to fill in with zeros. And then I'm going to write a nice pretty version down here without all the little bumps underneath it. Be careful to grab all the zeros that we need. And then every third digit, you add a comma, and don't forget that negative sign. All right, we will pick up tomorrow with some examples in our notebook, and we'll make sure you got it down. So be sure to show up with your notes taken, and if you have any questions, have those ready for me too. See you in class.